thank you for coming to my presentation. First off, I have a very disappointing news. I will not be doing it in Turkish. The extent of my Turkish is about tamam. So as you heard, my name is Christian. I work for Peak. I wanted to share some lessons and stories that we had during our migration to Kubernetes. A brief agenda about how we're going to structure this whole talk. First, there's going to be a little bit introduction about me. Then I'll talk about Peak and the Clouds team responsibility within Peak. I'll give you some numbers about the extent of our operation and also the decision why we decided to go with Kubernetes. I'll also show you where we are now, what lessons we learned, and what are our future goals going forward. So, I'm from Hungary, Budapest. It's a very beautiful city. Any Turkish person who went there loved Palinka and Langos. I really recommend if you go there, try those two. I came to Istanbul in around February. I really love this city and some very great foods, I can really say. Jar kebab is my favorite. Cannot get enough of it. So, I'm an expat at Peak. I moved here. Previously, I was working as a remote engineer, and now I'm a senior DevOps engineer. Basically, my job is to maintain and improve the infrastructure. Wrong. Great. So, Peak was founded with a very bold statement. It wanted to be one of the biggest tech companies in the world. First, it focused on games. Now, with stealth projects, we are moving into other territories as well. When I joined 2 years ago, we were around 50 people. Now we are over 100. Our games are present in around 193 countries with over 330 million downloads. The team is aiming to reach 1 billion, and sooner or later, we hope to be there. If you haven't downloaded it, Toyo Toon Blast, please do it, give it a try. If you have any feedback, please give it to me. I would be very helpful to learn it. Peak has a very different way of looking at the teams. We don't have any KPIs or numbers present to the teams. They make it for themselves. This gives them a freedom to do experiments and tests. And from these tests, a lot of good things have come out and a lot of innovative things as well. So, what is the Cloud team? The Cloud team is a very small team. We're only 5. Even one of our colleagues is working remotely. We don't have a team leader. We're self-organized. What does that mean? We're getting the pages, the alerts. We're maintaining the infrastructure, so we see better what we want to work with and where we need to take the whole infrastructure to. So we only have one chief operations officer who we report to if there's any outage or any problem, or even if we have a request for license or anything else. But we decide each week what we're going to work on. Our company is multi-cloud. We're in AWS and GPC as well. When we transitioned to a self-organized team, we had a very big talk within the team. We had to decide what our core principles are, what we were going, and how we wanted to do. And basically, we discussed that there is 2 customers for us. First, the users of our products. There are multiple backends, multiple products, and each one needs to have the best experience possible. Second, we also maintain our own infrastructure, like monitoring, Git with GitHub, and we have to maintain those. So our colleagues are also our customers in this case. And if any team has any problem, question regarding architectural or just solution, they come to us and we work together to solve those problems. And there are lots of challenges that we face, and not everything can be solved with open source or commercial tools. So we write our own tooling around it. And since we don't have like a strict coding rule of which language we use, everyone is up to use any language they want. We generally use Golang and Python, and most of our tooling has been open sourced. You can see it on this link. So to give you some extent about the size of our operation, our 2 games have 13 million daily active users, which translates to about monthly 32 million. Every 2 weeks, the product team releases 50 levels for free, and every second, our player base does around 1,000 levels. Quite nice. We collect information from these events, like if someone is stuck on a level or having problems with something, or just passing and how fast they're passing. And our big data pipelines process around 4 terabytes of data daily. And to back this up, in Medium, we have around 600 servers. Doesn't seem much. It's a very volatile environment, but it's enough to handle it. Every instance that we had is finely optimized, and we use the best instances for each purpose there. And these 600 machines range from the smallest micro instances to 24x larges for our databases in production. We consider ourselves a data-driven company. What that means for us is that from our backends or any service that we use, we write something called an exporter. We take data, metrics, values from it, and push it into our monitoring system, which is Prometheus, and we create dashboards, alerts from it. To give you two very good examples, in AWS, there's called something the scheduled events. We wrote an exporter for this. Basically, if there's a maintenance or anything going to happen, we have a deadline to take action on it. If we don't, there can be downtime in our production. So we took an exporter to get that event and export it into a monitoring. If before the deadline we don't take action for it, then we will get notified. The other one is a trusted advisor exporter. There are always best practices or recommendations that we need to do within the cloud. And sometimes if we do changes, we might not be according to that best practice. So we are an exporter to detect these anomalies, and then we can rethink our decision or our change and do changes according to the best practice there. The question comes, why Kubernetes? Kubernetes is not an answer to your problems. It will have problems of itself. It has a very steep learning curve to jump into it. And also, if you adopt it into your company, you have to change your tooling and your practices. So, in our case, there are more benefits to it. In our infrastructure, we have a very strong correlation between application and the instance itself. We don't run multiple applications on a single instance. So if, let's say, we want to do a new version upgrade to a newer PHP, for example, we would create a new environment, spin up it with a new version there, create changes in our Git repository to have that always in infrastructure as a code, and then we would deploy, test, migrate over traffic, and then shut down the old one. It took a lot of time and a lot of effort from us. With Kubernetes, doing some tests, this could be iterated much more faster. And also on Kubernetes workers, we can have a CPU or memory-hungry application living together. Our utilization is much more better in that case. Also, to scale up, we just add more workers to that pool. We don't need to look at specific ones. We just add the general ones that we have. So, where are we now? We have around 20 clusters. Some are dev, some are prod. One of our stealth projects is already fully on Kubernetes. And if we take our cloud's internal infrastructure, monitoring, exporters, and lots of other things, about 50% has been migrated. This helps us to understand problems that the developers might face or might want to ask or solve during their migrations. Also, Big Data team is helping us with this journey as well. They're deploying new services quite often, and the new services get deployed onto Kubernetes itself. So we come up with solutions and problems together. So what are the lessons we learned? First, when you jump onto anything, you need to really look at the competitors or other things that you can use. For our case, the first question was, which container scheduler should we use? Kubernetes was not the de facto standard that we chose. We could have gone with Mesos, Nomad, Swarm, Fargate, even more. We had to evaluate and look at each one and compare it to what are the benefits or the drawbacks of that. And then, as you can guess, Kubernetes was the winner. Great, we have a decision, let's go with Kubernetes. But how do we install it? First off, we took the very fundamental way. We took instances, deployed them, and we deployed every part of Kubernetes manually. Kubernetes the hard way. We understood how and what correlates to each other, what problems we can face, and how we can solve those. Then we took the trendy and even the fancy ways to install them. We deployed clusters with that tooling, like kops, Salt, kubesalt, or kubeadm, deployed clusters with that, and to see deployed applications even on how we can utilize. What are the drawbacks of using that? What is the drawback of migrating a cluster using that tooling? And in the end, we decided to go with hosted solutions. It's not ideal, they have their limits, but we will worry about limits when we get there. Currently, it's very fast and very easy for us to iterate over each cluster. When you go to internet, you will see a lot of success stories, all related to Kubernetes. But I doubt you won't see one success story. Take a financial institute. You will never see that we went to Kubernetes, migrated our financial app to it, and it just works, no problems. You'll never see something like that. It's always good to start off small. For us, this meant we took a VPN exporter. Within a company, we use VPN to provide access to people outside of the company into our secure and production environments. We also have an exporter to get metrics, how many people are there, how is their performance going. And we decided to use this one as the first one. So we deployed it to Kubernetes, we kept the old environment running as well, and we were waiting for some time to evaluate how it compares to each other. During this time, it's quite fundamental, but you can have two approaches. If there's a problem, you can solve it in scope of that ticket locally, or you can take a Jira backlog and solve it later. It's always good to expect problems. And as you grow, you will face newer and newer challenges. One very interesting thing for us was on AWS. When we expose a service, Kubernetes creates a load balancer, creates a security group, and attaches the two together to be able to communicate. Very simple, straightforward, you can get up running very fast. But there's a limit. Every AWS instance can have a maximum of 16 security groups. So after our 15th migration, we saw a problem. Communication was not going straight between them. So we researched, found an API gateway solution, which we deployed, and basically it just routes traffic to within our cluster, and it only requires one security group in that case. Also, if you do some reading around Kubernetes, you'll see lots of problems arise. Like after 1,000 or 2,000 nodes, there are very big performance impacts for it. In our case, we sat down, we thought about this, and in the end, we decided this is not a problem that we should worry about. We won't get possibly to that extent, and if we get to that extent, we'll worry about it then. Until then, we have a different journey to go through. If you go to a conference or read online, lots of times you have people saying, you have to use this tool, this is the standard, this is the only way to do it. Even for us, we had a similar situation. The previous place where I worked, we were using Helm. It just deployed, it's a very easy to use package manager, it has some drawbacks, there's going to be a rewrite to it possibly, but it was very easy. And when within the company we had the question, which package manager or how should we deploy applications, I just said, why not Helm? It's easy to use. And the team came back saying, okay, but what's the problem that it solves for us? So we thought a little bit, and then we decided to go the hard way. We wrote YAML files, deployed them with a Jenkins job, simply kubectl apply, and it just worked. It's not ideal, but it does the job. Then as we were spinning up more and more clusters, we had a little problems. We had to change some variables. There were some information that needed to be injected. So we thought about it. Then we went with a tool called Renderer, which is just a Go templating, and it's very easy to do. In the Jenkins job, we injected variables, it replaced it, and deployed it simply. And as we got to bigger and more heavy applications, we had even more dependencies. Like we wanted to, for example, generate config maps, or we wanted to change namings of different objects depending on the application. After some research, we found Kustomize.io, which solved our requirements very easily. To give you a little bit explanation, let's say you have a very basic application called the deployment. It just describes how that application looks within Kubernetes. If the user takes the base application, he can run it in his local environment. Then we would have a separate repository where we would have overrides or changes. For example, we would change the namespace to match our dev and prod requirements. Or even in dev, we could override the image with a dev version of that image. Maybe in production, we need to inject a different env variable, which would be like env production, which would make sure that some tracing or debug options would get removed. And this is how it would look basically. We would have a very basic repo anyone can use on their local machines. For product 1, product 2, we would have a separate repository with the dev and app prod version of the application. If a new product would come up and they would require this application, we just need to copy over those folders, and we just need to look what variables we need to change in that environment. It was very fast and very easy for us to iterate over it. When we sat down, we had lots of questions and topics we wanted to solve. And everyone from the team has a different perspective or different view. So what we did is that everyone gathered the topics or questions that they're interested or want to solve. We created a big list from it, and then we assigned priorities and severities to it. For example, how do we collect metrics from the cluster? There are lots of ways, like Heapster, cAdvisor, use a third-party tool, use a cloud-provided tool. In the end, we decided to use one of them. It's great, we have lots of data, but what to do with that data? We need to understand what we want to monitor. So we looked at all the metrics we had, we looked at best practices, what people recommend, and we found those metrics that we're interested in. It's great, we have the metrics, now what are good numbers? And there's not anything like a good number. We just went with our guts, this is what we want to monitor, this should be the level of it. And as we went with each iteration, we had to fine-tune those numbers. Each cluster is specific, it has its own characteristics. So we have to adopt those numbers to that cluster there. And every team who decides to go with Kubernetes will have different severities, different priorities. Don't take something for granted. Use your own team decisions there. For example, secret management. In the beginning, we were interested in secret management, but it was not a critical question for us. So we went by manually deploying the secrets. If we brought up a new cluster, we had to deploy the secrets manually, and it just worked for us. Then, about a couple of months ago, we decided to solve this problem. We got a tool from a secret management store. It automatically syncs over all the secrets, and we just migrated the apps to use the new secrets. It was the time, and it works. And as we were going over these smaller iterations that we discussed, these are the priorities, we had a very good sense of achievement. We saw a list of decreasing. It's not like a hat where you're just throwing in new tickets and it's never ending. That felt very good for us. One of the very early questions that we had are, what are the worker nodes? There will always be questions or things you cannot answer. There's too many unknowns, too many to jump in. It's much more simpler to jump in with a decision that looks ideal, but is not the best outcome. For example, we went with a compute and memory optimized instance, large size. And as we progressed, we went to extra large, to extra large. In other clusters, we went to 4, even to 5 nodes. Each cluster is different from that perspective. At that point, we always took the decision what looked like the best outcome, but was not the ideal. Looking back, we wouldn't do all those decisions. And also, if you make a decision, don't be scared to revert that decision. We decided to go with a Docker registry. We researched it, really liked the features, deployed it, it was working. Now we're seeing some problems. So we're researching a different version, and we will migrate over to it. When you do any action on a cluster, there's always going to be a workflow and consequences of that action, which you need to understand. For example, we have a 4-node cluster, 12 gigabytes of memory free. You scale up one of your deployments because you have a performance problem, and then job comes back successfully, yet you're not seeing the performance improvements. As we started to investigate why this was happening, we saw that the upscale was unschedulable. Kubernetes doesn't solve the problem to move over resources. It just deploys if there's enough resources. So we added a new node to that worker pool, and then it was schedulable. But then comes another question. The cluster was unbalanced. Older nodes always have more running on them, and newer nodes have less. So we needed to work on a descheduler to optimize out each cluster to that extent. Also, with config maps and secrets, there's a very interesting thing that we learned. If you do any change and deploy it, it doesn't automatically get deployed. You have to restart the pods to have it applied. And lots of people recommend to have like labels or any value that's changing, a git hash, a date, a Jenkins build variable to overwrite it. But the problem is, what happens if you do like a bump deployment or any deployment that doesn't change the config map or the deployment? In that case, you would just restart it without any value, and we don't like that. So we researched further and found a solution where we could look at the events updating the different config maps and only trigger updates when we met that certain event. Much more ideal in our situation. There are always best practices and guidelines that we follow within our environment. And sometimes we have to break our own guidelines as well. We have two applications, Grafana and ANSI. Grafana is basically takes data from Prometheus and is a dashboard to visualize all these data. ANSI is our dashboard for each Prometheus alert manager alert. So we can see all our currently firing alerts in that case. And these require to go to every environment that we have. So in our previous environment, we just opened security groups according to IP addresses. Moving to Kubernetes, this would mean that we would need to open the whole subnet, which was quite large in our case, to these applications, which we were not comfortable with. And not the ideal solution, but what we decided to do is create a new subnet, create a separate worker pool within that, add something called taints and tolerations, and only allow these applications to run there. And in that case, we just needed to open a small subnet of our small segment of our subnet to the applications. We have infrastructure and configuration in code. And as we were using it, it evolved with time. There are some practices that we didn't follow which were best. We were pushing to master. And as you can guess, master was unstable at given times. Not the best thing. So when we migrated over to Kubernetes, we decided to use a more GitOps-like approach. What that meant was that the master branch got protected, not even administrators could push to it, and everyone had to create a branch and do a pull request. Our big data team created a small application called PRLotto. It dynamically takes someone from the team to review your code, and only after he approved it could it be merged. And with this, we could catch a lot of small errors people were doing. We have lots of grand ideas or big ideas that we want to do. And with every day that we work on these, we feel we're working towards one progress. We have the possibility to define our own roadmaps, and I think this will be beneficial to our users as well. So, what about our future goals? Since we have lots of pull requests coming, there's a very good way to look at auto-testing, running some synthetic tests before merging them. We haven't done it, but it's something down the roadmap we would like to do. Also, since we're bringing up and decommissioning clusters, there's some extra work related to these, and we would like to solve that problem. So we want to write some tooling around that as well. You might have heard about Chaos Kong or Chaos Monkey. Within our own infrastructure, we like to break things. Oh, and I'm the best at it. And if we break things, we understand better how it behaves and what happens around it. So we want to write disaster scenarios on what we can do to prevent such issues. Also, since we're writing tools for ourselves, our developers are using these tools. And this gives them a very good empowerment. With Kubernetes, we want to extend our tooling to give them more empowerment there. And also, there are very good observability tools that work with Kubernetes or Docker native solutions. So we also want to do that. And since I'm a very lazy person, I don't like to wake up at night. And currently, we're getting too many alerts. So hopefully, with time, we can cut down on the alerts and make a more resilient system with it. Thank you.